Time for that DraftPhysics.com, debatephysics.com also. But as usual, nothing to debate. I mean, nothing on the subject, nothing reasonable, nothing fair. So we'll take care of a comment that, again, just is pretentious and arrogant crap, as if there's no real issue because they could just say some jargon and somehow that undoes the subject. That it doesn't, of course. So, I mean, I've illustrated this over. So it's like, look, I've said this how many times? 25 times the fuel to go 5 times as fast. I know it doesn't happen. You know it doesn't happen. And you should at least have the integrity to say that's a problem. I mean, we really can't be selling this idea that it's energy when you don't need it to do something you say you need to do it. I mean, it doesn't take 25 times the fuel to spin a motor 5 times as fast. It's just a fact. It doesn't happen. And that has a real consequence to your conservation and any other reasonableness to your physics. It has to happen. If it doesn't happen, there's something wrong with your theory and you have to revise it. You have to explain why it can't be collected. I mean, you're also dishonest. It's just so creepy. All right, so we've been over this part so many times. So if I have a Newton's cradle, and I move the, what the hell? Okay, I bang this one into this one. This one leaves with the 100% in, 100% out. Both kinetic energy and momentum are conserved. Everything is fine in the universe. And I'm just going to get a different color because I don't care for that. Yeah, I'll have to find the pause button. Alright, back. See how much color we have left. So now we're going to change the weights, and something, something happens. They claim that I claim I'm going to show how it's paradoxical and nonsensical. It can't really happen that way. Alright, so now, okay, I've made this twice as big. And now when I swing this one, okay, with 100 momentum, that is MV, into this one, I'm going to get 133 momentum, P, okay, this way, going this way. All right, so no conservation forward. And I'm going to get 33 by their 30 going back. Now, I would argue that's not what takes place. That what goes forward will be some lesser percentage of the momentum, and something like 80, okay, and then 20 will go back, but not what they claim. 66, I guess you would say. 66 forward and 33 back, okay. So way different theoretical prediction. And then, and that's because we're not using carts. So understand, if I did this experiment with carts, I can create the illusion, because the cart coming in, although it will be measured as having a linear velocity, okay, that's going to be half the speed of the twice as heavy object. Its linear velocity is actually higher than that. Its momentum is higher because there's a whole bunch of energy caught up in the rolling wheels, and they don't account for that. And then there's the whole problem of the spring interacting between them, and the fact that the spring is no good at giving energy back at a high speed. The higher the speed it gives the energy back, the less energy the spring, the less complete the restoration of the energy is. So two factors that ruin the track type experiments, and the reason why you don't want to be using springs and you don't want to be using wheels. So the Newton's cradle is very good because it doesn't have either springs or wheels. Okay. All right. So then the next step is, all right, I make it 3 times the size, and then I get 150, okay, going this way. So the same 100 goes in, and it's going to the garbage. And I get 150, okay, coming out. All right. So 100 goes in every time, and now I'm going to get 50 back. So now I've doubled, if you think about the total movement, I've doubled the total movement momentum. Now, I'm obviously saying that doesn't happen. What really happens is this is 75, okay, and this is 25, right? Yeah. Yeah, has to be that way. That's the reality. And obviously the next step, is just to go to the maximum, which is you hit it with the small thing going 100. You get 200, let's just say 199 to be technical, 0.9% extra, and then you get the complete 100 back. You get 99.9 back. So you've quadrupled the amount of total energy. Okay, now that's their assertion. So if somebody wants to show me any evidence of any physics lecture that says that doesn't happen, I can show Professor Lewin saying that's the truth. I can show different professors, college teachers saying that's the truth. That's what happens. All right, so just to be clear, that's their argument. And so I made the simple point that if you did put this experiment in space, you don't have any complications of the... Well, I really should be able to get that lighting better. Detail. Well, don't know if it's any better, but maybe it won't flare as much, which is better. Alright, so all I have to do is inject something moving in between the two. Alright, so I have a little ball bearing, and I'm going to give it a velocity in one of those directions. So it's going to be shot off of one of the surfaces, doesn't really matter, with, say, some mechanism. Alright, that's going to be doing the same thing by their definition. The launching mechanism will do the same thing. But let's just say we didn't launch it off one of these objects. We just had it hit in, and it's going to bounce back and forth between the two objects. Alright, and their theory says, okay, that this is the same experiment. I have a small mass hitting a large mass. So it's a 10-to-1 relationship, let's say. It could be 100-to-1 as I used in the previous example. It doesn't matter. And the absolute fact is that when the light thing hits this heavy thing, it's going to give this heavy thing 200. So even though it only hit with 100, it's going to give it 200. And they'll say that with an anvil. I can drop a ball bearing on an anvil, and it'll drop and bounce 200 times. And their theory says every time it hits the anvil, whatever its bounce back momentum is, that's how much momentum it put into the anvil. So every time it bounces, it's putting that much energy into the anvil. They don't think the reflection is an indication of a rejection of the energy. They think it's some sort of equal and opposite reaction. So the equal and opposite reaction wasn't to stop the object, right? The ball bearing comes down, and the equal and opposite reaction isn't that the ball bearing stops and this object absorbs the 100. They're saying the equal and opposite reaction is that it bounces. That means somehow the object absorbed the 100 and produced 100, another 100 somehow. That's their theory. Okay, so there's no denying it. And so it bounces off that surface, then hits the other surface and gives it 200. Okay, and it just keeps doing this. Then plus, does it again, 200, and then plus 200. And it just keeps bouncing back and forth between the two, creating more and more energy. Both of them are gaining momentum, and there's no denying that's what their theory predicts. Their theory predicts that I could eventually have these two objects going hundreds of times faster. I could have them going 10 times faster, let's just say, at least. Depends on how much mass there is. So if it's 10 times the mass, I can have them going, both of them going the same speed almost as the ball bearing eventually. And so it's 10 times the energy. 10 times the energy here, 10 times the energy here that I started with. That's the fact. There's no way around it. That's what their theory says happens. So, and he's there, the commenters just kind of claim, oh, no, that doesn't happen. Well, show me it doesn't happen. You have to link to evidence, and then I can show in the evidence you link to what the flaw in the experiment you're using is. But you're never going to counter anything I'm going to state as damn good evidence. The fact that you don't have a single example of a ballistic pendulum collecting a bullet's kinetic energy. Anything more than 0.06% of its energy. Okay. Anything more than a tiny percentage. They have ballistic pendulums that, where you can buy the whole kit. And so obviously it doesn't have thousands of joules going in. So the percentages wouldn't be quite as high. But it's still not more than the momentum. And the fact is that's all you can collect in the ballistic pendulum is the momentum. You can't collect the kinetic energy. All right. So this Dubai, bad name I'd say. Anyway, D33. Well, I'm here to tell you that that's not what the theory says. So you can tell me and lie, okay, but that's what the theory says. Professor Lewin says you should have a sleepless night over it. Because he's going to say the whole Earth gets moved. When the heavy object doesn't move and you get a 100% reflection, his argument is the whole Earth moved. And so every time the ball bearing hits the anvil, his argument is the Earth is now rotating faster and faster. Your bouncing ball bearing example has free kinetic energy in it, so it doesn't. So where does it have free kinetic energy in it? So it's just a lie. See, I can't stand comments like this. It's just such a lie. Where? I didn't create any free kinetic energy. They're heavier things moving. That's less kinetic energy. The heavy things have less kinetic energy. And again, I didn't write your formula. It's not my fault. Okay, that the thing starts going faster and faster and faster and you end up creating eventually free kinetic energy. But it doesn't start that way. After the first bounce, there's not free kinetic energy. It's only after the second and third and fourth bounce that you have free kinetic energy. That's not how the physical reality works. Well, that's my argument, that your theory doesn't work. It's so weird you still haven't learned the two simple rules. They're meaningless because they're not true. Okay, so he says... 1. Total momentum is always conserved. That's my argument, but you don't have a definition of total momentum that's rational. You think because something goes this way and something goes that way, it's zero momentum. So again, I can use this argument that I used the other day, that it's not zero momentum if I have the simple example of the brick wall and a spring, and I shoot an object. Where's the equal and opposite reaction? I have zero momentum to start. I release the spring, and all of a sudden now I have something moving with a definite momentum in this direction, and there's nothing moving in that direction. So where's my equal and opposite? Where's any of that? It's non-existent. It doesn't show up anywhere. So there's really no point in telling me total momentum by your definition is conserved, because obviously it's not conserved. Because you're going to play the game. When it's movable, okay, when this object is movable, you're going to say, oh, well, now we do the subtraction math. But when it's not movable, you're not going to do the subtraction math. 100 minus 0 is 100. So you start with no movement, you end up with a bunch of movement. See how it doesn't work? You're such hypocrites. Anyway. Total momentum is always conserved. The conventional definition of total momentum, i.e. direction, matters, as Newton said. So that's just a lie. Newton didn't say that. Newton said you want to go twice as fast, use twice the force. You want to go 3 times as fast, use 3 times the force. He said nothing to indicate he believed in mv squared. So just lie some more. See, it's all just lies. All right, kinetic energy is conserved in elastic collision, so it doesn't mean anything. It doesn't. It's kind of obviously not conserved. In the sense that you can't create an elastic collision with a heavier object and show me that conservation, in the sense that you've just demonstrated that you're saying in this elastic circumstance the thing will never run out of energy if I do it in space. If there's no air resistance, then mechanically there's very little losses. And again, the anvil thing, if I did the anvil thing in space, it's going to bounce a lot more than 200 times. And it's going to keep putting energy into the heavier object. By your definition, not just energy, momentum. All right, that's it. What's so difficult here? Well, you're just a liar. It doesn't matter if you agree with those rules or not. Well, I clearly don't agree with any of it because I'm saying there's no evidence supporting it. And the very fact that the lever disagrees, the balance, says that different ratios are equal to each other. The fact that you can't diagram the launching of a rocket and demonstrate how kinetic energy has anything to do with it. And then the ballistic pendulum, another huge giveaway. And then these illogical experiments that you claim an outcome, but you really haven't proven it. But that is what the theory says. So again, the whole argument is the theory's nonsense. It doesn't happen. Those aren't the rules. All right, why did you have to bring the problems of real-life springs into the theoretical thought experiment? I didn't. There were two separate arguments. And regardless, they're real arguments. The fact is springs have two fundamental flaws. Well, one flaw of the spring, that is, it does fast motions less efficiently than slow motions in terms of giving energy back. So that's the great inefficiency of a spring. The fact is it can't give the same percentage of its stored energy to faster things that it can give to slower things. It's just physics. It's a physics fact. So it's kind of important to bring it up because it's really relevant when you're using a spring to measure something. All right, when the answer is staring you in the face. So there's no staring me in the face. But anyway, launch a two-mass object with a spring and both get the same momentum in opposite directions. Launch two-mass objects. Yes. But the point will be is if I put it in a 2-mass and a 4-mass, will the 2-mass still be moving the same velocity? And the point is no, it'll be moving a lesser velocity. All right, then replace one of the 2-mass objects with a 1-mass object, and what happens? The spring becomes less efficient, is what happens. Okay, you know that the 2-mass object will now have less momentum than the 1-mass object must have the same amount in the opposite direction. What I know will happen is that the heavier mass will move slower by the conservation of momentum, the numbers I gave, 75, 25, that kind of thing. Less momentum than the 1-mass having the same amount of opposite direction. So we know that that's what you claim. And I would argue that that's the extra over the amount that would be a reasonable expectation. I mean, obviously you're saying 133 for a 2-mass, and then you're saying 150, for a 3-mass, and then it just keeps going, 166, and then 85, and then 199. So whatever extra I get in one direction over the 100, I'm going to get that much back in the opposite direction. So when I finally hit 200 going forward, I still have 100 coming back. All right. You know the 2-mass object will now have less momentum, and the 1-mass object must have the same amount in the opposite direction of momentum. Even with a perfect spring, but that's the whole argument. What's your definition of a perfect spring? This conserves momentum in the conventional sense, but breaks your idea of momentum conservation. The only thing breaking the idea of conservation is the fact that the spring has efficiencies, and the slower it gives the energy back, the more energy it can give back. The faster it has to give it back, the less efficient it is. That's the argument and the fact. And if we want to do a little bit of math, we can see that kinetic energy is also conserved. It's not actually conserved. So it's not about doing math. It's about accurately measuring experiments. And the fact is that the experiments don't come out that way. They're already off. because it's a demonstration of the fact that springs are really causing the effect, and this has nothing to do with conservation of kinetic energy. It has to do with the fact that you are remaining ignorant about the variables that are actually in play in the experiment. So the fact is the angular momentum of the wheels matters, and the fact is that the speed that springs can release energy being variable also matters. And you don't care about that science, that truth. Those facts you wish to ignore as being the cause, okay, of the fact that, yes, you can steal the energy from the lighter objects and make them look like they have less energy than your theory would claim. Which makes sense, as the spring should have the same energy and the same compression, and obviously they don't, for the reasons I've stated. Okay, somebody says, let's debate. What is that, even with some sort of silly emoticon? Obviously you can't do it, right? Debate requires you to be able to draw a picture now and then to, show what you're talking about. And none of you weak asses can do any of that. You can't explain where there was a lie in any of these drawings, or where there was a mistake made by me, or a statement that wasn't true. And instead you just lie in the comment section about how, oh yeah, no, we already took care of that. No, you didn't. You haven't countered any of these arguments. None of them. Not a single one. Alright. So I'll pause and see if there's anything else worth mentioning. I guess I could just mention this. So there was some other comment. I finally deleted it. Some guy brought up Ken Wheeler, and who was the other guy who brought up? Mathis, and then a few others. Okay, Bill Gatey. As if I haven't heard of these people, and that as if I haven't responded to their theories and explained what I see as being ludicrous about what they claim. The fact that there's so many of these Ken Wheeler nuts, it just surprises the hell out of me, because his theory is so silly. I mean, it's ether. It's so why don't you go back 1,000 years to a bunch of mysticism, because it's just that. Hyperberloids, all kinds of, all kinds of swirly weird shit, for which, the straight, simple lines of the underlying universe is simple. It isn't complicated. And Ken Wheeler wishes to state that all of the elemental physics is full of woo. But anyway, it doesn't, they're all bad. Rope theory, bad idea. Electric universe, bad idea. Really bad. I mean, it's just so silly, because we know electricity has no function in vacuums. It has to have a conductor. You can't just throw electrons around. Just a fact. They don't like to be thrown around unless they're inside a conductor, unless they have a path that's been cleared for them. Then they're, pretty much stopped from going anywhere. You can't throw them across space. Alright, so that's probably it. Let's see, you seem to have accepted, so that's always a bad way to start a fucking comment. I didn't accept anything. Okay, so that's just bullshit. That there's a limit to the size of stars. I've made the point that there's obviously a limit to the size of stars. You don't need to even try very hard to figure that one out. That obviously the stars do have a size limit. Just silly for anybody to believe otherwise. According to Sky Scholar, so another pile of crap channel, stars are condensed matter. Well, duh. Liquid or solid? Well, liquid only through intense heating. So, do you know any evidence of a star size limit? I'm just saying that we know from what can be seen with telescopes, and there's obviously nothing to indicate that there is anything bigger than, say, 1,000 or 5,000 times the size of our sun, something like that. And that's as big as they can get. Alright, anyway. Yeah, I think that's it. Yeah. All right. So I don't know if it's worth going to find some other crap. I have to, I'll do a few more videos to the other science channels that I haven't gotten to yet. Where they just, all the silly claims about how the universe works. And it's just, again, all unevidenced crap. And I don't know why there's so many people defending unevidenced crap. I'm just surprised that intelligent people don't mind being worse than religious people. I mean, at least some religious people will admit they don't have any evidence. They admit that, yeah, it's just a feeling I have, blah, 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 something like that. But, for all these intelligent people to sit there and slander the truth and lie about who Newton was and what he believed, that surprises me. But I've already stated I was surprised that intelligence doesn't come with integrity. I just didn't see how the two could be inseparable. I mean, I didn't see how you could separate the two. I still don't. But I have to accept that you figured out how to do it, assholes. That you could gain knowledge of the world, that you could read a few books, even a Dr. Seuss book, and be lying scum. Thinking that being lying scum works is great theory, great practice. It's all about winning. It's not about winning fairly, honorably. It's just about your side winning, right or wrong. Who cares? Just sucks that you're all such low character scum. Sucks. And the physics is, I'm just saying, it's unanimous so far. 60 of these channels challenged, 60 of, at least 40 of them offered more, $2,000 or more, and they won't defend their bullshit against my accusations. Because they're stinking, lousy